In this video, let's see the topic on pile driving method. First of all, myself, B. Chellapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So, in pile driving method, there are two types, displacement pile and non-displacement pile. Displacement pile is nothing but the pile is driven by using a hammer, etc. In non-displacement piles, the piles are driven by a boring process. So in displacement pile, there are four types: dropping weight, vibration, jacking and jetting. In non-displacement pile, first one is under-rimmed pile. So drop hammer method. In drop hammer method, the hammer is raised and rose above the pile head for driving purpose of pile into the soil. There are four types. Steam hammer. In steam hammer, there are single acting steam hammer, double acting steam hammer. And second one is diesel hammer, vibration and jetting. In first one is single acting steam hammer. In single acting steam hammer, it is raised by using a steam or compressed air. Here the hammer is freely falling weight called as a ram, in which the air is to be admitted into the cylinder. It rises up the piston rod. Next, and it is controlled by the operator. When the steam is cut off, the cylinder falls freely on the pile helmet. In double acting pile hammer, the steam pressure is applied to the underside of the piston, raise the ram. Then, during the downward stroke, steam is applied to the top side of the piston. It increases the energy per blow. In double acting steam hammer, the number of blow per minute will be approximately twice to the single acting steam hammer with the same energy rating. Next one is diesel pile hammer. In diesel pile driving hammer is a self-contained driving unit. It does not require any external source of energy as a steam boiler or air compressor, etc. It is a simpler and easily moved from one location to another location. So diesel hammer, it consists of a vertical cylinder, pistons, fuel tank, etc. Here, after the hammer is placed on the top of the pile, the combined piston and ram are lifted to the upper end of the stroke and released to start. As the ram nears the end of the downstroke, it activates the fuel pump. So, due to this ignition of the fuel, the resulting explosion drives the pile driving downward into the soil. Next one is pile driving by vibration. By vibration, the piles are being driven into the soil. It is usually by electrically powered or hydraulically powered. Next one is jetting. Jetting means the penetrating the pile into the sand or sandy gravel. The water jetting can be employed. And this method has a limited effect in frame of stiff clay or any soil containing much coarse-grained soil. Next one, non-displacement pile. In non-displacement pile is a boring pile and it's below, it comes under the under-rimmed piles. So under-rimmed piles are a bored cast in situ pile having one or more bulb found by enlarging the borehole of the pile. Here, there are two types of under-rimmed pile. That is single bulb cast in situ pile and multi-bulb pile. In single bulb attached at the bottom of the pile is called a single bulb under-rimmed pile. If two bulbs are attached at the pile means then it is called as double bulb under-rimmed pile. If more than two means then it is called as a multiple bulb pile. Generally, the diameter of under-rimmed bulb is kept equal to the 2.5 times the diameter of the pile stem. So this is a figure for under-rimmed pile. Here first by augering process we are making a borehole. Next, under-rimmed are to be inserted and reinforcement are to be placed in the bulb and filling the concreting. So procedure, it consists of a spiral auger, under-rimmer and boring guide. Here spiral auger is used to drill a hole into a ground, and cutter is attached at the bottom of the auger to easily digging a ground that is excavation of soil to a recorded type. So excavation is carried out by the auger only after passing through a handle. After digging the hole, the bulb to the required depth are to be inserted. Next, the auger are to be removed and casing of reinforcement is inserted into the hole after concreting is done. Here, all the piles are connected each other by forming a beam at the head of the pile, and wall is constructed over the beam. So this is a figure. First one is augering and second one is under reamer with blades. Next, advantage of under reaming piles. So such pile are 50 to 20% cheaper than the strip footing. Less material is required. No heavy digging equipment is used and no need of backfill in such piles. And shoring is not required and dewatering is also not required. Next one is disadvantage of under reaming piles. So here skilled required for placing of such type of pile and required good workmanship and maintaining vertically in a ground is very difficult and required strict and regular supervision with good quality control. Next, group capacity by different method. There are three formulas. That is, first one is conversion lapse formulas. That is eta g equal to 1 minus theta divided by 90 into n minus 1 into m plus m minus 1 into n divided by m1. Here m is number of rows and n is number of pile in a row. Here theta is calculated by tan inverse of ds. Here d is diameter pile and s is a spacing of pile. Second one is Sealer-Kinnis formula. Sealer-Kinnis formula eta g equal to 1 minus 0.479 s divided by s square minus 0.093 into m plus n minus 2 divided by m plus n minus 2 plus 0.3 divided by m plus n. Here s is an average spacing from center to center. And next one is Fed's rule. Fed's rule, it is reduced by 1 by 16 on account of nearest pile in each diagonal or straight row. So spacing of pile is not considered. Let's see one example. Here in the figure, the efficiency of corner pile. So I am seeing for a. So in this figure, let's see a corner pile. In corner pile, there are 3 piles are passing. That is 3 adjacent pile. Therefore, eta equal to 16 minus 3 divided by 16, which gives an 81.25. Next, for central pile, there are 4 piles are passing. Therefore, 16 minus 4 divided by 16, which is equal to 75%. And average of these two values gives us 80%. Next one is group actions. Here, generally, the piles are used in a group with a common pile gap. A group may consist of 2 or 3 of piles or many. So, therefore, it is given as a QUG equal to N of QUN. So, QUG is a load carrying capacity of a group pile and N is a number of pile and QN is a pile at is individually. Next one is important one, that is a negative skin friction. While pile driving, there is an existence of some frictions. So one of these negative skin friction. It is usually a downward drag, shear drag acting on a pile. Due to this, the pile group, the downward movement of due to the downward movement of the pile, the surrounding soil related to the piles may to cause. And what are the factors that cause the negative skin frictions of the pile? Or when the fill is loose, cohesionless, or if the fill materials deposit over the soft layer, or here the uneven settlement of piles, or the piles are in compressive soils, and bearing pile the settlement of the pile is negligible, become the pile capacity problem. So negative skin friction in a single pile. The negative skin friction in single pipe. The first one is when the piles in coaxial soil, Fn equal to PLCAC. Here Fn is a negative skin friction, P is a perimeter, L is a pile length, and Ca is a unit adhesion. Ca is we can written as alpha into Cu. Here Cu is a undrained cohesion of a compressible layer. Next one is negative skin friction in cohesionless soil. For cohesionless soil, Fn is 0.5 P L square gamma K tan delta. As a negative skin friction on a pile group. So Fn equal to n into Fn. Therefore, CuLcPg plus gamma LcAg. Here n is a number of pile in a group, Pg is a perimeter of a group. So in this video, we have seen about the pile driving method and the negative skin friction. Thank you.